Linear graphs and modelling. This is looking at using linear graphs, including our graphics calculator, for real-life scenarios and making predictions. So for example, a tomato plant was 5 centimetres high when it was first planted. It grows at a constant rate of 6 centimetres per week for the next 10 weeks. Write a rule for the height in centimetres over the time in weeks. Now, they've given us a real-life scenario and they've given us the variables that we will use. If they hadn't given us the variables, we would have to define them. So if we just stopped there in the question, we would have to say, let height be the time, or let h be the time, height, and let t be the time in weeks. But they've told us, so we don't need to. What you want to look for is your dependent and your independent variables first off. Now, time is usually independent, and thus it usually goes on the x-axis. And to check that, identify your variables, so time in weeks there, and height, and they've identified them anyway, height and time. And ask yourself which one depends on the other. The height of the plant depends on how long it's been growing for. Sounds good. How long the plant has been growing for depends on its height, not making as much sense. So you're usually looking for which one of those sentences makes more sense. So we've identified that our independent x variable is time in weeks, and so our dependent variable is y. And we go to our y equals, now we can use y equals mx plus b, or we can use y equals a plus bx. It doesn't really matter. The textbook uses this one, so this is what we'll use. Remembering, of course, that our gradient, which we used to call m, gradient, this is what changes every x. So since x is time in weeks, what changes every week? It is a 6 centimetre gain. So that's a positive 6. Our a, which used to be our c, is our starting point, or our y-intercept, and we start at 5 centimetres high. So early on, it's a good idea to just clarify that you know what you're doing here. Then we have to substitute everything into here, and we're going to change y and x as well, because y is actually our height. We start at 5 centimetres plus 6 times the time in weeks. So the rule for the height given time is 5 plus 6 centimetres per week. Now we need to be able to use that and graph it and do all sorts of things. Notice that they've told us this relationship only continues for the next 10 weeks. After that, maybe the growth slows down. So if I was graphing this, I would only graph it when time was between 0 and 10. And you'll see this little domain definition quite a lot. It's just saying, graph this for time between 0 and 10. Now, if you were graphing it, chances are you'd graph that on the graphics calculator. So you would remember y equals, enter your rule, you have to use x. And we could do all sorts of things like, now I've left my stat plot on. If you get something that you don't expect, like dots, when you've done y equals, chances are you've left your scatter plot on. You can just reset your memory if something's happening that you don't understand, but you can also go into stat plots and turn it off. Now if I try zoom 9 for a quick graph, it's thinking a lot. That means I've set my window up. I'm going to have to go in, look at my window settings. So that means you've got to do it the correct way. Have a look at your table setup, starting at 0, going up by 1. Great. Have a look at your table of values. I need to go up to x equals 10, so y needs to go up at least to 65. So you have a look at our window. No good here. Have to start at 0. X has to go to 10. Y can start at 0. Y has to go up to above 65. And that should be sufficient to graph it. There we go. So if any of those errors turn up, that's the thinking that you've got to go through to get your graph happening. Now, we have a rule, and we've got 2 questions. You can use algebra to answer these. So we'll do that very quickly. Question A, I want the height of the plant at 8 weeks. So 8 weeks means t equals 8, and I want to find height. Height is 5 plus 6t. Height equals 5 plus 6 lots of 8. 6 times 8 is 48. Height is 53, and it was a word question, so you give it a word answer. Therefore, the plant is 53 centimetres tall after 8 weeks. Oh, sorry, my writing went terrible there. My bad. I do apologise. So you can solve that just by solving the equation. You can do that for this one as well. The time it will take for the plant to grow to 20 centimetres. So they've told me the height is 20. I need to find time. Write your equation. Height is 5 plus, oops, it should have been a gap there because I'm doing a different equation now. Same there, really. Height is 5 plus 6 times t. I know the height, substitute it in. And now solve that to find t. Subtract 5 from both sides. 15 equals 6t. Divide by 6 on both sides. T equals, 15 divided by 6. 2.5. Therefore, it will take 2.5 weeks. Now, if I was in a test and I was in a hurry, I'd just pop weeks on the end of that and leave this and come back to do my word answer if I knew that it takes me a long time to think of, okay, what should my word answer be? You know, it's little tools to try to move faster through a test, but that does mean you've got to come back and check it off. So you might find it's easier just to do your word answer at the time. Now, you can do this and you can check this with your graphics calculator. If you are told an x value, then graph your line and go into calc, which is second function above trace, and use 1 for value. And it will say x equals, your x was 8, hit enter, and it will tell you your y value of 53. So, if you're given x, graph it, then second function, calc, which is over the trace button, and 1, and enter your x value, hit enter, and it will give you your y value. And that is fine. If you want to solve this that way, state pretty much your working would be x equals 8, calc on GC, y equals 53, and you would have to still give your word answer. A little bit trickier for when they give you the y value on the graphics calculator, but it can still be done. One of the easier ways is to graph the y line. If y, that is h in this, equals 20, go back into y equals and do a second line where y equals 20. Have a look at what happens when I graph. It shows the intersection. Now I've got to actually remember how to get this happening. And I hope it's calc and intersect, and hit enter. So what it's going to ask you is to say, where is the first curve or the first line? It's here, sure. Yep. So that one's the second one? Yes. So it's just saying, please let me know that these are the two lines you care about. Then move your cursor pretty close to the intersect of those two lines and say, look, I think it's around there. That will say the intersection where y equals 20, x is 2.5. So you can see that that got our x value for us. So when you're trying to get an answer when you've been given y, graph the y line as well. Value, whatever the value is, then do second calc intersect, and you will have to choose each line. Sorry, I shouldn't have moved to pink there, that's very unreadable. So if you do that, you'll get the value of x given y.